Okay, charging by induction, I mentioned during the introduction that kailangan mo dito ng isang neutral object and kailangan mo dito ng isang charge object. Pero ang kanilang interaction ay no contact. Ilalapit mo lang pero hindi mo sila pagdidikitin. Okay? So for also, by the way, no, in this method of charging, dapat meron kang solid understanding of how charges distribute themselves sa isang conductor. Diba? Yung conductor, they allow free movement of electrons doon sa kanyang surface. And then second, dapat naunawaan mo din yung polarization. Diba? When we say polarization, one side of the object become negatively charged and another become positively charged. Dahil may presence ng isang charged object na nakaka-attract or nakaka-repulse ng mga electrons papunta sa side na yon. So this is composed of 4 diagrams. On the first one, makita natin yung, yan na naman, yung classic natin, no? Metal sphere. Meron silang handle sa baba na insulator para hindi makatakas yung mga charges from the metal sphere. So, in this particular example, meron tayong dalawang metal sphere, A and B. So, both of them are neutral. And then, on diagram number 2, we can see that naglapit ka ng isang charged object, which is negative balloon, halimbawa. So, from the previous lecture, alam natin kung paano mag-react yung electrons from this negative object. So, lalayo sila from the negative object, di ba? So, yung mga electrons dito sa A, lalayo sila from the balloon. So, pupunta sila sa side na to. Fortunately, makadikit yung sphere A and B, di ba? So, dahil ayaw talaga nila, di ba? They are repulsed by the negatively charged object. Magkakaroon ng mass migration. Magmamigrate itong mga electrons from sphere A to sphere B para ma-maximize nila yung distance nila from the negative object. Okay, so in this way, makikita mo na meron ng polarization na naganap, di ba? So, sphere B, for the most part, or overall, is negatively charged. While sphere A ay, dahil iniwan siya ng mga electrons, siya ay positively charged. Okay, huwag kayong malito dito ha. Hindi lumapit yung mga protons. Remember that they are stuck in the nucleus. Positively charged lang sila kasi naiwan siya ng mga electrons. So, may polarization between A and B. But, if you think about the whole system, and I say the whole system, sphere A plus sphere B, whole system sila. Makita mo na neutral pa rin yung charge ng, kung i-consider mo ang parehong A and B, if you will consider them as one. Kasi, halimbawa, ito, plus 5 coulomb siya. Tapos yung B, negative 5 coulomb. So, di ba, if you add them, if you get the sum, you will get 0 kasi plus and minus 5. If you consider the two sphere as one, they are still electrically neutral. But separately, sphere B is negatively charged and sphere A is positively charged. Now, when you separate them, that's the moment na nagiging charge bodies na silang dalawa on their own, di ba? So dahil nilayo mo na yung sphere B, what happened to the how did the electrons distributed themselves? They stay away from each other then, di ba? So aside from being repulsed doon sa or repelled dito sa negative balloon, remember that they are also repelled by each other. So, nung nilayo na sila doon sa sphere A, they now have the chance to move away from each other as well. Such that, mayroong uniform distribution ng negative charges doon sa sphere B. Pero if you will look at sphere A, nandun pa rin. Polarized pa rin yung side na ito. Kumbaga, positively charged pa rin yung side na ito. Dahil nandiyan pa rin yung balloon na negatively charged. But, once na nilayo mo na yung balloon na yon, which you can see in diagram number 4, what will the electrons do? Diba sila naman lagi nag-a-adjust? They will partner with this side, yung mga atoms na nasa side na to, such that yung buong sphere A ay magkakaroon ng equal distribution din ng excess protons. Okay, remember, they don't think for themselves. They think for the betterment of the whole. So, gusto nila, pantay-pantay silang nararanasan ng repulsion. So the same thing is happening here, essentially. Ang difference lang ay, meron kang, yung nilapit mong charge object ay positive na ngayon. Okay? So, ganun ulit ang mangyayari, no? Dahil positive na siya, ma-attract naman niya yung electrons. Diba? Dahil conductor yung sphere A and B, pwede magpalipat-lipat yung electrons, diba? From B to A this time. So, again, as a whole, if we consider the spheres as one, they are electrically neutral. But individually, yung sphere B ay naging positively charged na, and yung sphere A ay naging negatively charged. Again, if you separate now the sphere B from A, mag-adjust na naman yung mga natirang electrons sa sphere B. Pag-partner-partneran nila yung excess proton such that uniform yung distribution ng excess proton over the surface of the conductor. Dito, ganito pa rin ang arrangement kasi hindi pa naman naalis yung balloon. But, once na umalis yung balloon, the excess electrons here will also distribute themselves evenly doon sa surface ng object. Okay, again, law of charge conservation ay present dito, no? So, before and after, wala tayong dinagdag or binawas na charge. The charges or the electrons simply migrated from one sphere to another. So, if you can see here, for the sake of illustration, if you have 5 electrons here, diba, nung nagkaroon na ng polarization, you can still see them here, the 5 electrons and the 5 protons, even after nag-separate na yung spheres. Diba? So, there was no addition or subtraction of charges. Only transfer of charges, movement of charges. So, if you treat them as a system, again, so if this is negative 5, this is positive 5 coulomb. So, overall, if you treat them as 1, so you still have 0 net charge. Okay? But again, individually, if you treat them individually, may kita mo na positive 5 coulomb, halimbawa, itong sphere B. And negative 5 coulomb, halimbawa, itong sphere A. Okay? I'm only using it as an, as an argument, yung coulomb, 5 coulomb and negative 5 coulomb. Hindi ibig sabihin na makita ka ng 5 plus sign. Ibig sabihin, ano na yon? 5 coulomb na yon. Positive 5 coulomb. I'm only mentioning it for the sake of argument or discussion. Okay? So finally, we will talk about charging by conduction on the next and last video lecture.